Have you ever wondered how machines see the world around them? This fascinating question takes us into the realm of visual perception and its digital counterpart, computer vision. Visual perception in humans is a complex process. It starts with light striking the retina, creating an image that our brain interprets as the world around us. We see objects, colors, movements, and so much more. Yet this process is so seamless and immediate that we often take it for granted. But what if we could teach machines to see the world like we do? This is where computer vision comes into play. Thank you for joining us here at Innovative Muse, where we explore innovation as it meets technology. Welcome in. Computer vision is a scientific field dedicated to enabling machines to view, interpret, and understand the world. It's like giving sight to the blind, only in this case the blind is our machines and computers. It's about creating algorithms and systems that replicate our own visual perception to understand and interpret the visual data they encounter. The journey of computer vision begins with image acquisition. Here, the system captures a digital image through a camera or a sensor, much like our eyes capture the light that falls on our retina. But this image is just raw data. It's like a newborn looking at the world, seeing light and shadow, but not understanding what it all means. To make sense of this data, the system undertakes pre-processing. Here, it refines the image, removing noise and enhancing features, preparing it for the next steps. Then comes feature extraction. The system identifies key elements in the image, such as edges, textures, and colors. It's like when your eyes focus on the sharpness of a knife, the roughness of a tree bark, or the vibrant red of a rose. Object recognition follows, where the system identifies the objects in the image. It's like recognizing that knife, that tree, or that rose for what they are. Finally, scene understanding allows the system to interpret the overall context of the image. It's like understanding that the knife is in a kitchen, the tree is in a forest, or the rose is in a garden. In essence, computer vision is teaching machines to see like us. To understand how computer vision works, we must first delve into its key components. The anatomy of computer vision can be broken down into 5 main parts: image acquisition, pre-processing, feature extraction, object recognition, and scene understanding. Let's kick things off with image acquisition. This is the first step where a digital image or video is captured. Think of it like our eyes first seeing an object. The quality of the image acquired can greatly impact the success of the subsequent steps. Next, we move on to pre-processing. This is akin to the brain's initial processing of what the eyes see. In computer vision, this involves improving the image in ways that increase the chances for recognition. This could be reducing noise, enhancing contrast, or correcting illumination, among other things. Then comes feature extraction. This is where the computer identifies important elements or features within the image. It's like when you look at a face and discern features like eyes, a nose, or a mouth. In computer vision, these could be edges, corners, or textures that help differentiate one object from another. The fourth component is object recognition. This is where the computer identifies what the object is. It's similar to how you would recognize a face as your friend's. For a computer, this could mean recognizing a car in a street scene, or identifying a tumor in a medical image. Finally, we have scene understanding. This is the culmination of all the previous steps. It's the equivalent of not just recognizing your friend's face, but understanding the entire scene, knowing you're at a coffee shop, seeing your friend sip a latte, and understanding that she's enjoying her drink. In computer vision, this could mean understanding a city street with moving cars, pedestrians, and changing traffic lights. These components work in harmony to give machines the ability to interpret visual data. They form the backbone of computer vision, allowing machines to see and understand the world around them, much like we do. As the field of computer vision evolves, so do its techniques. Let's delve into some of the advanced techniques that are revolutionizing computer vision as we know it. Deep learning, a subset of machine learning, is one such technique that has provided significant breakthroughs. It uses artificial neural networks with multiple layers, hence the term deep, to model and understand complex patterns. In the context of computer vision, Deep learning can be used to identify objects, people, and even emotions in images and videos. Object detection, another advanced technique, is not just about recognizing what an object is, but also pinpointing its location within an image. This is crucial for applications like autonomous driving, where the system needs to identify and locate pedestrians, other vehicles, and road signs in real time. Next up is semantic segmentation, which takes object detection a step further. It's not just about identifying an object and its location, but also about understanding each pixel's role within the object. This detailed level of understanding enables more complex image analysis, like separating foreground from background or differentiating between overlapping objects. Then we have 3D computer vision, which brings the element of depth into the mix. By interpreting 2D images in 3D, we can gain a better understanding of an object's size, position, and orientation in space. This is particularly useful in robotics, where machines need to navigate the real three-dimensional world. Lastly, we have generative adversarial networks, or GANs. These are a pair of deep learning models that work together. One creates a fake image, and the other tries to determine if the image is real or fake. This process continues until the fake images are almost indistinguishable from the real ones. GANs are used to create realistic artificial imagery, from faces to landscapes. These advanced techniques push the boundaries of what machines can visually perceive. They allow for more complex image understanding, thereby improving the capabilities of computer vision systems. This, in turn, opens up a world of possibilities for their application across various fields, but we'll get to that in the next scene. Computer vision is not just a fascinating scientific field, it has real-world applications that are transforming industries. Let's start with healthcare. Computer vision is revolutionizing this sector in multiple ways. It aids in the detection and diagnosis of diseases by analyzing medical images. For instance, it can identify patterns in X-rays or MRI scans that the human eye might overlook. This not only speeds up the diagnostic process, but also improves its accuracy. In the automotive industry, self-driving cars are no longer a concept of the future. They are here, thanks to computer vision. It allows these vehicles to perceive and understand the environment around them, enabling them to navigate roads safely. It's like giving cars their own set of eyes to detect other vehicles, pedestrians, and obstacles. Moving on to the retail sector, computer vision is enhancing customer experiences. It powers the technology behind cashierless stores, where customers can simply walk in, pick up items, and walk out, with the payment automatically processed. It's also used in virtual fitting rooms, allowing customers to try on clothes without actually wearing them. In agriculture, computer vision is being used to monitor crop health and detect diseases early. It helps in precision farming by identifying which areas need more water or fertilizer, leading to increased crop yield and sustainable farming practices. Security and surveillance is another field where computer vision is making a significant impact. It's used in facial recognition systems, crowd monitoring, and anomaly detection, enhancing security measures and ensuring public safety. Finally, in the entertainment and media industry, computer vision is behind the magic of augmented and virtual reality. It enables these technologies to blend the virtual and real world seamlessly, providing immersive experiences. From healthcare to entertainment, computer vision is reshaping industries. It's exciting to imagine what other transformations this technology will bring as it continues to evolve. Despite its impressive progress, computer vision still faces significant challenges. One of the most daunting is the complexity and dynamism of our world. While computer vision systems excel at recognizing objects in controlled environments, they often struggle in the wild. Real-world scenes are dynamic, cluttered, and unpredictable, making it tough for algorithms to accurately interpret and respond. Moreover, computer vision systems are still limited in their ability to understand context. For instance, they might identify a ball and a person in a picture, but fail to grasp the concept of playing catch. This contextual understanding, second nature to humans, remains elusive for machines. not to be overlooked are ethical considerations. As computer vision becomes increasingly prevalent, it raises questions about privacy, consent, and bias. How do we ensure these systems respect individual rights and don't perpetuate harmful stereotypes? These are critical questions we must address as we continue to develop this technology. But amidst these challenges, the future direction of computer vision is filled with potential. Advances in deep learning and artificial intelligence are opening up new possibilities for growth and innovation. We can expect improvements in object detection, recognition, and understanding. We might even see computer vision systems that can interpret complex scenes almost as well as humans. In the realm of healthcare, automotive, agriculture, and entertainment, computer vision is poised to revolutionize how we interact with the world. As we overcome these challenges, the future of computer vision looks promising. In this journey, we have learned about the science behind how machines see. We dove into the basics of computer vision, understanding its key components, from image acquisition to scene understanding. We explored advanced techniques like deep learning and 3D vision, and saw its diverse applications across healthcare, retail, and more. We also looked at the challenges faced and the exciting future directions. As we continue to teach machines to see, we are not just creating smarter technology, we are redefining the way we understand and interact with the world around us. If you like this video, please hit the like button. We value your feedback, so feel free to leave a comment. Also, if you want to see more content like this, please share this video and subscribe. Until next we meet, be well.